Good morning, class.
Good morning, teacher.
How are you today?
We are fine, thank you, and you?
Thank you. I am fine too. I am glad to see you. Sit down, please. Let's start our lessons, okay? So, look at the board and try to guess today's topic. What did you see? What did you see? What do you see? Yes, person. Laws, yes. Then, what is it?
3 laws.
Yes, 3 laws. Yes, 3 laws.
And 2 laws is law.
And the man say what? Say force. Yes, force.
About force, Mars.
Yes. Okay. Then, what today's topic is? Newton's laws. Yes, Newton's laws and the force. Yes. Okay. Thank you. Today's topic is forces and the Newton's law. Today's learning objective is to create possible algorithms of problem solving when bodies are in motion under the action of forces. Okay? Yes. Write down in your notebook today's learning objectives. Okay, let's watch the video for understand today's topic. Okay, today's topic.
To get there, even how fast it's traveling. Here is a wooden apple resting on a countertop. Before seeing anything else, you've probably made a number of assumptions. We readily think that the marble counter is heavy and rough, and that the apple is smooth and light. Say we plan on giving the apple a shove to the right. We all have an idea of how the apple will slide and stop. Thanks to our intuition, we can make predictions like this on a moment-to-moment basis without much effort at all. But what if it were possible to remove everything that our intuition is based on? What if we could remove all the air in the room, which can cause air resistance? Remove all the friction from the ground and walls, and remove the force of gravity. Now if we pick the apple up and let it go, it won't move anywhere because there's absolutely no force acting on it. If we bump the apple now, would it ever stop moving? The truth is, once we give the apple a bit of velocity, it stays at that velocity, moving in a straight line until it's bumped again. This isn't just an imaginary experiment. It turns out that this is exactly what happens in outer space.
Okay, what do you understand when you watch the video? Okay, hands up please. Okay.
In the first part of our video, they wanted to explain us that our everyday, we may say that our everyday physics roles is the main part of our life. And after the second part of our video, they wanted to understand. They want to show that the 3 laws of Newton is the main part of the laws of physics. And as a matter of fact, they wanna to show us the force, the definition of the force.
Okay, thank you, Marjan. Sit down, please. What about laws? Students, what did you say about it? Who wants? Please, Dilnaz.
So Newton has 3 laws. I think first law is an object at rest will stay at rest, and an object in motion will stay in motion and constant velocity unless acted upon by an unbalanced force. And the second law is force equals mass times acceleration. And the third law is for every action there is an equal and opposite reactions.
Okay, thank you, Dinas. Good. Okay, listen please. Pay attention. I'll give you worksheet and you must make the poster. I'll give you worksheet. You must make the poster about today's new topic. Okay? I'll give you 10 minutes for this. Okay, have you finished it? Yes. Who wants to present your posters? Okay, come in, please. Come on.
Newton's first law of motion. Newton's first law is often called the law of inertia. Every object continues in its state of rest or of uniform velocity in a straight line as long as no net force acts on it.
As you see, forces are balanced and they divided into two groups. First is objects at rest and objects in motion. And as you see, objects at rest, their velocity is equal to 0 meter divided by second, and their acceleration is also equal to 0 meter divided by second square, and they are still stay at rest.
Okay, thank you. Sit down, please. Good. Please, come on and present your posters, please.
So the next law, the Newton's second law, is about the motion, about the acceleration. The acceleration depends directly upon the net force. The acceleration depends universally upon the object mass, and the more force, the more acceleration.
Newton's second law of motion describes the relationship between an object's mass and the amount of force needed to accelerate it. Newton's second law is often stated as FMA, acting on an object is equal to the mass and object times acceleration. That's all.
Okay, thank you, Nuray. Danaya, sit down, please. Good. And 13, please. Come on and present your poster.
So, first is the push or pull, and I want to start from my words. Some actions, some forces, result of contact interactions. So, for example, I could make only two examples for this. Here we may say that force is, we have the two types of force, downward and upward. And these two types of forces can result of the action. And as you have seen, I may make still one more example. Is when you sit in your chair, your body will give this chair the downward action, downward forces. The chair will give for this body is the upward actions. That's all.
Okay, thank you. Sit down, please, Biket and Marjan. Thank you. Good. Okay, at home, you must read the topic and solve the problems. Okay? Stand up, please. Thank you for today's lesson. Goodbye.